Subscribe to AmpCode and ring the notification bell to get the latest content.
So let's talk about the stateful transformation in Spark streaming and how it can help preserve the state of the previous window of your Spark streaming application for many use cases. So basically we are going to see what are stateful computation and also the stateless computation, and what are the advantages as well as the disadvantages and the different use cases for each of them transformations. So the first one is the stateful transformation. So the stateful transformation is a particular property of Apache Spark streaming which enable you to maintain the states between these micro batches. So micro batches are nothing but the data which is coming in real time and a smaller chunks of this real time data. That is nothing but a micro batch of the data. Since Apache Spark streaming is near real-time analytics platform. It is not the real-time but the near real-time analytics. So we mostly achieve this stateful transformation by creating the checkpoint or the checkpoint directory on the streaming applications. We are going to see this, how to create the checkpoint directory or the checkpoints in your Spark streaming application in the subsequent topics. But using this stateful transformation, we can use some data of the previous window or the previous batch to generate the aggregated result or the combined result for the new batch. So there are specific use cases which needs this stateful transformation. Let's talk about them now. So as you can see, these are few of the use cases which needs the stateful computation or the stateful transformation. So for maintaining the aggregated results over time. So as we already know, for getting the aggregated output, you shouldn't only rely on the result which is given by that batch, but you need the result of the previous batches as well and get the aggregated results over time. So if your use case needs to count all the records that are coming in and get us the aggregated output for many batches or the number of batches that you require, then you have to maintain this using the stateful transformation. Also for performing different computation over a window of data. So basically if you have a specific window, let's say if you want the aggregated output of all the transactions that are coming in for the 12 hours. So if you need the aggregated output of the 12 hours and your batches are coming at a 5 minutes interval, then you need to get the state of all these previous batches and get the computation done on the previous data as well. To get that, you have to use the stateful computation or the stateful transformation to able to save your status of this data in some checkpoint. And if you have to keep track of stateful information like the user session in the continuous stream. So to do that, you need only the stateful computation, but it comes with different advantages and the disadvantages. Let's talk about them now. So basically the stateful transformation will enable you for a sophisticated processing capabilities. Many of the use cases that we have seen will only need the stateful computation, and we are going to see next how the stateless computation are not suitable for these use cases. And also it facilitates like complex computation which depends on the previous data also. So for historical context of your data, of your real-time data, then you need the stateful computation. But there are like several disadvantages as well for this stateful computation. The first one is it requires more resources because you are keeping the historical data as well to calculate the aggregated output. So basically your Spark application to have work more to get the status of the previous execution as well, then aggregation as well, and also keeping the track in the checkpoint directory. There is so much overhead in this application when you use the stateful computation, and also it is very complex to manage due to the need of maintaining the state of your Spark streaming application. So we know that many of the use cases will need the stateful computation, but it comes with its cons as well, like the more resources that are needed to run your Spark application and also the added complexity for managing this complex logic. Now let's shift our focus to the stateless computation and let's see what are the different use cases and the pros and cons of that approach. So as the name suggests, it is stateless. So in stateless streaming, it is like independence and it aims for scalability. Let me tell you how it works. So stateless streaming is nothing but you have to treat each piece of your data or the each micro batch of your data as the independent entity. They are not dependent upon the each other. Let's say if your data is coming at a 5 minutes of interval, each batch of 5 minutes, let's say if you receiving like 100 records per 5 minutes, then you have to keep that as an independent entity, and the computation that you're going to apply on these micro batches will not depend on each other. So this approach will ensure that each data point or the each micro batch is processed in the isolation. Let's say if you want to count the records coming in every micro batches, you cannot use the aggregated output. You have to isolate this operation as per the micro batch itself. So you will get the count of each micro batch independently, and you don't have to worry about like keeping the track of the previous executions or the previous aggregation operations. And also like stateless streaming is very simpler to implement, as well as it is very scalable because it doesn't need much resources as compared to the stateful computation, and also it is very suitable choice for scenarios where independence is the paramount or the priority. So let's talk about some of the use cases of this stateless streaming as well as its pros and cons. So if we talk about the use cases, if there are like several tasks in which each data point is processed independently. So if you just want to focus on those aspects of the use case, like only getting the aggregated output of a particular window. So if your data is coming in micro batches of 5 minutes, then your window is 5 minutes. Basically, if you need to have like aggregated output or some transformation on top of the data, then it should, and it is limiting to that particular batch, then stateless computation is the right choice for you. And also there are like many situations where there is no need to reference the last past data or the historical data. You just need to make the decision in real time on the latest data itself. So for that purpose, maybe stateless computations are the way to go. So there are like different advantages to this approach. First one is the simplicity in the implementation. Also we have the scalability. So scalability due to the independent nature or the independent processing of this particular micro batches, which gives us the scalability at the highest priority. But it also has the disadvantages. So it is not suitable for the application which requires the knowledge of historical context. So historical data is the main concern for you to get the aggregated output, then you should go for stateful computation or the stateful transformation. But if you don't need like the historical context or the knowledge of your data, then stateless computations are basically good choice for you because it will give you the simplicity as well as the scalability for your Spark application. Also it has like limited handling scenarios, right? So the stateless computation will have very limited use cases as well as limited in the handling scenarios that demand the context aware processing. So due to this, it totally depends on the use case that you have and what are the outcomes that you need from your Spark streaming application. So this varies based on use case to use case and your data, and also like what data you're handling. So we are going to see all about how to implement these stateful computations, because stateful computations are more used and more likely used in the production environment. So we'll see how to implement this in the next lecture.
So that's it for today. I'll see you in the next lecture.